All right, vectors. They can seem a little intimidating, right? But honestly, just think of them as a map for a journey. Today, we're going to break down a pretty challenging GCSE vectors question, step by step, and I'll show you exactly how to lock in every single mark. Let's get into it. Okay, so here it is, our challenge for today. Question 19 from a higher tier paper. Now, at first glance, it might look a bit complicated, but I promise you, it's just a puzzle. All the clues we need are sitting right there in the question. Our job is to piece them all together. Right, first things first, we've got to get our bearings and really understand what the question is telling us. It's super important to identify all the known paths and relationships before we even think about starting our journey. So what are we actually given to work with? We've got our basic vectors. OA is vector A, OB is vector B, and AC is KB. But then we have these two absolutely crucial relationships. M is the exact midpoint of OA, and N splits the line BC in a 4:5 ratio. These little details, they're the building blocks for our entire solution. Okay, so our main goal, the big prize, is to find the vector that gets us from M to N. But here's the catch. We can't just go there directly. We're missing a piece of the puzzle. So our very first mission is to figure out the path from B to C. So we can't just jump straight from B to C. There's no direct path laid out for us. But with vectors, that's never really a problem, is it? We can always find another way around using the paths we do know. So take a look. What path could you take from B to C using only the vectors we have? Here's a little pro tip for these kinds of problems. When in doubt, go back to the origin, O. It's almost always a safe bet. So a great path to take is from B to O, then from O to A, and finally from A to C. This means we're going backwards along vector B, which makes it negative B, then forwards along vector A, and finally forwards along KB. And check this out. This is straight from the official mark scheme. It confirms that writing down the expression BC equals negative B plus A plus KB is the perfect first step. It gets you a mark straight away. That tells the examiner, yep, this person knows what they're doing. Awesome. So we've got BC sorted. Now that we have that essential piece, we're ready to tackle the main event for part A, calculating the vector all the way from M to N. So, same drill as before, we need a route from M to N using paths that we know. Take a look at the diagram. What do you think is a sensible journey to take? And you guessed it, heading back to the origin is a fantastic strategy again. One of the cleanest paths you can take is from M back to O, then all the way across to B, and finally up to N. This journey is great because it uses vectors we either know already or can figure out pretty easily. Now, this is the really important bit. We have to turn that journey into a proper vector equation. So the path from M to N is equal to the vector MO plus the vector OB plus the vector BN. This is our roadmap for the rest of the calculation. Now, let's break that down piece by piece. We know OA is vector A, and M is the midpoint. So if we're going from M to O, we're going backwards along half of A, which gives us negative 1/2 A. Easy enough. OB is just B. That was given. And BN? Well, remember that ratio, 4:5? That means the whole line BC is split into 9 parts total, and BN gets 4 of those parts. So BN is simply 4/9 of the vector BC. Okay, get ready for the algebra part. Don't worry, we'll walk through it step by step. First, we pop in our components into the equation. Then, we swap BC for that big expression we found earlier. Next up, we have to be really careful and expand the brackets. And finally, we just tidy everything up. We group all the A terms together and all the B terms together to get our final simplified expression for MN. And just like that, part A is done. But of course, there's a part B. And it's a classic follow-up question that really tests if we understand the answer we just worked so hard to find. We need to figure out if our vector MN is parallel to another vector. So here's the question, plain and simple. Is the vector MN, which we just found, parallel to the vector OB? Let's just put them side by side and take a look. Our expression for MN has both A parts and B parts. But what about OB? Well, vector OB is simply B. There's no A component at all. And here's the golden rule for parallel vectors. One has to be a simple multiple of the other. That just means you can multiply one by a number, like 2 or -3 or 1/2, and get the other one. You're just stretching or shrinking it. You can't introduce a whole new direction, which is exactly what the A vector represents here. So the answer is a big, clear no. And the reason, and this is what gets you the mark, is that MN is not parallel to OB because you can't write it as just a number times B. That pesky A component makes it impossible. Okay, before we wrap up, I want to show you a super useful exam tip. For a question like this, there isn't just one single way to write the correct final answer. Let's see what the mark scheme actually accepts. So check this out. Depending on how you decide to tidy up your algebra at the end, how you factorize it, your final answer might look a little different from someone else's. As you can see, the mark scheme allows a few different versions. The most important thing is that you simplify your answer and that it's mathematically the same. So don't panic if yours looks a bit different.
And there you have it. That's how you can absolutely smash a top grade vectors question. You just break it down, follow a logical path, and piece it all together. So I'll leave you with this little challenge. We chose the path MOBN. What other routes could you have taken? Could you have gone via points A and C? Thinking about these other ways is a fantastic way to really deepen your understanding. Thanks for joining me.